video. This one not part 4. It'll be something else. Yeah, I've been doing some thinking, and so I just thought I would talk about some of the things I've been thinking. And really they really got so many things wrong. I mean, sorry, but yeah, that's the way it looks. When it comes to what's really happening in the universe. So I was thinking about, Venn diagrams. They produce this high voltage and, the kind of thing where you can put the fluorescent bulb, in the midair and it lights up because there's a difference in potential across a fairly large distance. And how that's kind of a strange phenomenon to explain. And so then I was thinking about some other stuff. I was thinking about what a ground means, and what positive and negative charge means, and how exactly electrons would associate themselves with something like magnetism. Because you would think, it's all made of this same blue and red stuff, that somehow electrons would be highly motivated by magnets. They're not highly motivated, surprisingly. They're motivated, but it's a subtle kind of effect, not a strong effect. If you really want to affect an electron, you have to have a pretty strong magnet. So I thought about that too, because when they do this thing for the electron spin experiments, they have to put them under a very strong magnetic current to get them to do what they want, to set them up. Not a weak, very strong. And you would think with electrons this would be easy to get them to move around. And it's not so easy. So I was thinking of different things. I was thinking about the difference between an electromagnet and a regular magnet, and the different ways these things function. So I guess one part I was thinking about what magnets are doing in terms of creating force, and they really are just filtering it. So I mean, as much as it seems like they're making something, they're just changing something. So the force that would be created is the same force that would still exist if the magnet didn't exist. The gravity would still be there. So instead of this being red at the bottom and blue here, it would just be a mixture of red and blue without the magnet. The force would still exist because the magnet's not creating it, it's just filtering it. That's really important. There's no extra force being created by a magnet. It's just converting what already exists, changing it subtly, switching it, blue here, red there, segregating it. But that's it. It's not creating any new force, and that's an important distinction. All right, the other thing to understand is, well, just for reference, even when something gets hit with a red or a blue, it's an electron, for example, it still gains momentum from either one. And figuring out exactly how much momentum is kind of a little tricky, but the truth is both forces push electrons in a sense. If a blue hits, it does this reflection thing, which essentially just means it takes energy that was going this way and turns it into energy going that way. And obviously the force coming this way is doing the same thing, so it requires an extra force for it to gain any momentum. But it does gain it if there is extra. And in the case of the red-blue thing, whether it's extra or just regular field energy, it is doing a reflection thing, which is kind of interesting in the sense that one thing comes in and it actually gains two momentums out of it. The one momentum being the extra arrow forward, which might be just a reversal of going this way, but let's just say it wasn't a reversal. And it gains a imbalance in its left to right potential, which turns into a momentum. Even though there's no extra energy, it's a momentum because of the imbalance. The imbalance creates the momentum. But it's all stuff that'll lose quite easily because of what I explained before, how the field energy is going to keep cutting off any imbalances that exist. And rather, in a certain amount of time, it will degrade any velocity that electrons have if left to pure field energy. If it has no sustainable current, no sustainable movement of the electrons. They stop moving as soon as the current, the flow, the stream stops. Alright, so that sort of needs to be understood. Alright, so then I was thinking about ground, and that I was thinking of it as, okay, it's a neutral pressure. It's not low pressure, it's neutral pressure. So the Earth is really like the free electron pressure. It's not high, it's not low. And you can go lower or you can go higher. And what the pressure really represents is the blue stuck between electrons. So the electrons are all blue, they get blue stuck between them, it bounces back and forth like a ping pong ball, as I was explaining before. And depending on how many of these blue things it has trapped between it, will dictate how far apart these electrons are, because they're all going to want to try to make the number of hits the same. So obviously if it has more pieces, there's more hit potential, so if you put them further apart, then they'll get hit the same. So if this one has 4 and some other one has 2, 2 would be twice half the distance, because half the distance would be the same number of hits as 4 from this distance as 2 from this distance. So electrons are all the same, even though I drew them kind of misshapen. But what happens is if they're in association with each other, which they really can't help but be, they will attempt to create a distance that creates an even pressure on each one. Say if there was any uneven pressure, that electron would move towards other electrons, which would cause them to move, which cause them to move. So this is how all of the matter is linked. This is the tension that holds everything together. So I was thinking about that, and thinking, see, the problem I was having was thinking about how when electrons are associated with, say, the red force, which is associated with protons. So this is essentially concentrated proton force, and you would think the electrons would be very, very attracted to it. But in a sense they're not, because as the red force comes out, what it's going to do is it's going to give you this push. So this is the, you have to kind of turn this picture that way, unfortunately. But let's just consider this is the red magnet down here. So this is the plus side of the magnet. And so the red is coming out and hits an electron. What does it do? The electron goes off at an angle, likely, because yes, it's going to convert. So that means the red energy will go out of the electron, and the electron will convert something going this way or this way into something going forward, which means it loses something going this way or this way, which means it has an imbalance, so it will go forward perhaps in this direction. Perhaps. It might go straight, it might go this way. Those are its choices. But it's going to go away from the proton initially. It's going to go away from the red force initially. And I was thinking that, yeah, so it lacks, we know why electrons hate electrons. It's because there's another electron here and the ping pong ball effect is happening. And so you can't push them together because the force gets much too fast. The ball hits way too many times, too much force, they get pushed apart. So that's true for proton on proton, and that's true for electron on electron. And so as I stated before in another video, there is no real attractive force. And so what you really need is a force to push the electron into the proton. And if there is no force, the electron is not attracted to the proton. So there essentially is no real attraction. The electron kind of has to be pushed into the electron. So that's why electrons don't crash into protons, is because they're not all that interested in protons. They just really hate electrons. And I've said this before, but that's really the game. So if you think of this Venn diagram thing, it's producing all of these, it's shooting electrons up, so it's basically just a ball on the end of a thing, and they have a belt running, and the belt is basically scraping electrons off or throwing up this way, and if it's turning the other way, it's throwing the electrons off. So it's either throwing electrons on or throwing electrons off. And when it's doing that, it's also throwing the force between the electrons. So these are charged electrons in the sense that they have a lot of blue between them. So there's a lot of ping pong balls going back and forth. And that's called the voltage, basically. And so that pressure is powerful. And so it's pushing against the other ones and forcing them to get, to expand. And so everything's expanding out. So you get all these electrons getting further and further out into this field. So they have the highest potential here. And obviously as it does get further out, they can relax. There's less pressure, so they can relax. And then it goes all the way to the ground, which is a neutral. It's not the ground isn't negative voltage, it's just neutral voltage. It's in between all the way negative and all the way positive. It's somewhere in between high pressure and low pressure. So if you create a high pressure, the idea is that you're creating the electrons have more pressure between them, more ping pong balls bouncing back and forth than these neutral ones that have a steady. So these have a steady distance. These electrons would have a distance, let's just call it neutral D, ND. And this distance is now bigger because of the voltage, the higher voltage, the more energy between the electrons, and also the fact that you're putting more electrons into the area. So the more electrons you put in is like adding electrons to this image here. If I put another electron in here, I create more pressure. If I put another one in here, I create more pressure. So everything starts bouncing more the more electrons I shove into an area. And so that's the increase in the voltage potential. That's how you increase voltage, by increasing the number of electrons, is you're basically just creating more pressure because you're putting more electrons in between electrons and creating more energy between them, more bouncing of the ping pong balls. And that's the voltage. But the real game is that there's a ton of electrons. So, you know, we all have this, I think, impression that the air is not full of electrons, that space might not even be full of electrons, but it is full of electrons. They're everywhere. They're almost like this field energy, in the sense that they're like the arrows I've driven going all directions. There are electrons everywhere, and you can't detect them really, you know, until you do something aggressive. You know, place charge near them, and then they manifest. But there's a lot of them. And so when one of these Venn diagrams, this thing might be 8 feet tall, and you'll have a charge that goes all the way down to ground, and it's just full. This whole atmosphere is just full of electrons. This is all electron pressure. The whole thing is just full of electrons. It's like a fog of electrons, and those electrons are the thing holding the pressure, carrying the pressure. And so all you have is a difference between the pressure of the electrons here, because there's more of them keep flying out here, so they're compressing, they're creating more energy, and there's more neutral here, and that's really your voltage difference. And vice versa, if you scrape the electrons off into the opposite process, you take more electrons, pull electrons out of here, take away these electrons, and you'll end up relaxing the pressure between these electrons, and they are now compressible. They can now move closer together. So I just think this is it's a very significant change in how I understand how things function, because electrons are everywhere. And another thing was, thinking about the two-slit experiment, is really, it really becomes clear that if you understand that between any two material subjects, there's all these electrons are always on the surface. So the surface is always going to be just like blue, 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 because there's a ton of electrons. And so any force that's trapped between them is going to bounce back and forth and bounce back and forth. And if I make the slits narrower, I'm going to create more of that force. I'm going to create more of that electron pressure. The electrons are going to fill this area because they've got less place to be, and they're less comfortable. So they're going to move towards the other piece of matter because you're compressing it. There's less room for them. I guess is what I'm saying is think of the two slits and just say if you had 100 electrons in here, and then I make the slits this wide. Well, now there's still 100 electrons in here, and now they're being compressed, and they don't like it. Okay, it's creating higher pressure, voltage, and so they're going to move out. And this actually happens in real experiments. You could put 10 volts on these two plates that are this far apart, so you could have plus 10 volts, this would be the neutral, 0. You could have plus 10, and then as you push the two plates together, it becomes 100. And then you push them a little closer together, you make it 1000 volts. So just by pushing them together, you're compressing the electrons. That's the work. That's the work that gives you the extra voltage, that gives you the extra potential to do work, is that when you're pushing them together, you're actually pushing the electrons. You're compressing them. and you're giving them more potential to expand, and that's the energy in. And yeah, so it really explains a lot. So the standard model of electrons spinning around atoms and all of that, it's all wrong. These things are dead quiet, except they're vibrating all over the place. They're Browninging motion like crazy. So they are jiggling a lot, and then when they actually do move, they move not straight. And the photons are this. This is photons. Photons is the energy between them. These are the photons right here. This force between the ping pong balls, that's the photons. And they're released when an electron goes this way and this guy goes the opposite way, and then the ping pong balls can get loose. That's your photon. Yeah, so anyway, I know this doesn't look terribly clear, but man, this was another big step forward, was understanding how electrons are so big a part of this. Free electrons are a huge part of what's going on in any atmosphere, any environment where forces are being exchanged. They're doing the exchanging. They're intimately involved in this whole process. And the ones that are stuck in the matter, yes, they're important when you start heating things or you're doing something, because you're starting to fuck up the ones that are bound electrons. But these free electrons are controlling so much of the interaction between material objects. The free electrons essentially are the ones that give this matter the reason why I can't put my finger through it. The reason why matter's hard is because it's electron on electron. It's those little damn ping pong balls. The reason why I can't stick my finger right through me, I can't just stick my finger through my head, is because the surface electrons and these electrons, they're compressing the little ping pong balls, and you can't compress them. It won't allow you to. So it's really quite interesting. So anyway, so I, a little change of pace before I get back to the, out the truthers and, defend my integrity against these liars. And the quality of the work I've done over the last 5 years, which is a lot of work. Again, I find it disgusting. These people will malign my qualifications when, again, I have done extensive research and I have spent a lot of time attempting to model and understand. And it hasn't been a small investment. I've taken all my free time, my casual time, my movie time and such, and devoted it to this purpose. And it's just fucking irritating to have these assholes tell me I haven't earned a right to speak, as I have. Okay, anyway. Till next time, such good stuff.